Welcome to the Trending Tech Show, where we break down the technology that's shaping our world. I'm your host, Alex, and today we're diving headfirst into a question that's been on everyone's mind. How do large language models, those AIs that seem to know just about everything, actually work? If you've ever chatted with a virtual assistant, asked ChatGPT to write a poem, or marveled at a computer generating images from your words, you've experienced the power of LLMs. But what goes on under the hood? To help us untangle these digital brains, I'm joined by Adam, an AI expert with hands-on experience in building and researching large language models. Adam, thanks for joining us.
Thanks, Alex. It's great to be here. LLMs are changing the way we live and work, and I'm excited to help demystify how they function.
Fantastic. Let's hook our audience right away. When people hear large language model, they might picture sci-fi robots or supercomputers replacing writers. But in simple terms, what actually is an LLM?
A large language model is an AI system that learns to understand and generate human language by analyzing massive amounts of text data. Imagine a kind of super-powered autocomplete, one that doesn't just predict your next word, but can write emails, pass medical exams, answer your questions, or even write computer code. What sets LLMs apart is their ability to pick up on context, nuance, and even humor, making them feel remarkably human-like in conversation and comprehension.
That's a great analogy, a supercharged autocomplete. Why does understanding how these models work actually matter for people listening, whether they're in tech or not?
It matters because LLMs are touching nearly every aspect of our lives, sometimes in ways we might not realize. They assist doctors with diagnoses, help lawyers sift through mountains of legal text, make customer support faster, and even create content and art. But beyond their usefulness, understanding how they work also empowers us to spot their limitations, like bias, errors, or resource use, and make more responsible decisions about when and how we should trust their outputs.
So the more we know, the smarter we can be as users, or even creators, of AI. Let's break it down then. Can you walk us through the main ingredients or architecture of an LLM? How is it built?
Absolutely. The backbone of almost every modern LLM is the transformer architecture, introduced in 2017. Let me give you an analogy. If you think of understanding a book, we don't just look at words individually. We think about sentences, paragraphs, and chapters. Transformers use something called a self-attention mechanism, which allows them to weigh every word in a sentence based on its relationship to all the other words. Imagine reading a paragraph and paying attention to how every sentence connects. That's what self-attention does for the model. Another important component is positional encoding, which preserves the order of words. So the AI knows that the cat chased the mouse isn't the same as the mouse chased the cat. And then there's multi-head attention, which lets the network focus on multiple relationships or meanings at once. Sort of like if you were watching several plots unfold in a movie at the same time.
That's a really clear way to describe it. So, instead of reading one word at a time, the model's got hundreds, or even thousands, of little spotlights paying attention to relationships between every part of a sentence or document. How does a model actually learn all of this, though? What's the training process like?
That's a good question. Training an LLM is a bit like teaching a child a new language, but instead of giving it a dictionary, you show it billions of examples of real language. Books, articles, dialogue, code, you name it. The model's job during training is to predict the next word in a sequence over and over, learning grammar, world knowledge, facts, and styles from context. This happens across huge data sets using powerful GPUs, specialized hardware for complex math. But it's not just read more, learn more. There are sophisticated optimization algorithms that help the model converge on what makes sense. It's a bit like fine-tuning a musical instrument after each song, gradually improving with every note.
When you say it's trained on huge data sets, what does that actually mean? Are we talking about books, the internet, or something else?
Pretty much all of the above. LLMs are trained on terabytes of text pulled from public websites, books, Wikipedia, academic papers, and sometimes even computer code repositories. The idea is to expose the model to the full richness of language, different topics, dialects, writing styles, even slang. Some specialized models will also be trained on industry-specific data, say for healthcare or finance, to master the language, concepts, and requirements in those fields.
That's a lot of words. Can you help us visualize the computational power needed? We hear numbers like billions of parameters. What does that actually look like in practice?
Think of a parameter as a little knob the model can turn to weigh different features. It learns about language. Modern LLMs like GPT-4 may have hundreds of billions of these knobs. Training a model at that scale can cost millions of dollars and require supercomputers strung together with thousands of high-end GPUs running around the clock for weeks or months. As an example, Google's Palm model, which has about 540 billion parameters, took around $8 million and a huge amount of energy to train. It's like running a small city's worth of servers, all dedicated to teaching a digital brain how to talk.
Wow, so it's not just smart, it's also super energy hungry. Are there innovations to make this process more efficient?
Definitely. There's been a big push towards efficiency and scalability. One clever approach is the mixture of experts architecture. Think of it as a team of specialists where only a few are consulted for any given question, instead of the entire group speaking at once. This greatly cuts down on the computing needed for each answer. Another key innovation is quantization, which reduces the precision of calculations in ways that save memory and energy, with little drop in accuracy. There are also optimization tricks, like mixed precision training or gradient checkpointing, that streamline how data is stored and calculations are performed during training.
It sounds a lot like adjusting the resolution on a video. Sometimes you can dial down the quality a bit and barely notice the difference, but you save a ton of bandwidth. But with all this power, aren't there also risks, like bias, errors, or hallucinations?
Absolutely, and that's a critical challenge, because LLMs learn from whatever data they're given. If that data contains biases, outdated stereotypes, or errors, the model can internalize and repeat them. There are also phenomena we call hallucinations, where the model will confidently make up answers that aren't grounded in reality. To tackle these issues, researchers are developing frameworks like constitutional AI, where models are trained to adhere to certain principles or ethical guidelines and constantly evaluated for accuracy and fairness. Many organizations implement human-in-the-loop systems, with experts double-checking outputs, especially in sensitive settings like medicine or law.
Let's get practical for a moment. Can you share some real-world examples of how LLMs are being put to work and where they've made a tangible difference?
Sure. In healthcare, language models like Google's MedPalm are helping answer complex medical questions and support doctors with decision-making. In the legal world, firms are building in-house AI tools to analyze massive legal documents and ensure data privacy. Financial companies use LLMs to detect fraud patterns in transactions. In manufacturing, companies automate maintenance predictions through AI-powered language models. And in hospitality, chatbots personalize guest recommendations and streamline bookings. Even in energy, companies like Shell use LLMs to analyze operational data and forecast customer demand. Some creative uses include text-to-video and content generation technologies, where AIs turn written descriptions into compelling visuals or music.
It almost sounds like there's no field left untouched. But with so many applications, what about the barriers? Are there challenges when it comes to scaling or making these models widely accessible?
There are certainly hurdles. Training and running LLMs is resource-intensive, so deploying them in smaller businesses or on edge devices is tough. But new advancements are making this easier. Smaller, optimized models need just a fraction of the resources, and techniques like quantization or sparse attention can drastically reduce hardware demands. There's also an important movement towards open-source models and more energy-efficient designs, so the technology can reach more people and organizations globally.
For organizations that want to adopt or fine-tune these models for their own use, what are some best practices?
First, start with a clear understanding of your goal and data. Collect the most relevant, high-quality examples for your domain. Use parameter-efficient fine-tuning techniques, such as LoRa or QLoRa, to adapt existing models to your needs with fewer resources. Always prioritize data privacy and security, especially with sensitive data. Continuously monitor and evaluate output, and consider strategies like layer freezing or discriminative fine-tuning, where different parts of the model are fine-tuned at different rates. And finally, always include human oversight, especially if the output will have significant impact.
Before we wrap up, what should listeners take away from all of this? If you had to summarize, what's the big picture of how LLMs work and what's next?
I'd say LLMs are incredibly powerful tools that learn by analyzing massive amounts of human language, Using sophisticated techniques to model the relationships and context found in that language, they're advancing rapidly, becoming more efficient, more scalable, and more ethical, while spreading into nearly every industry. But with great power comes the responsibility to build, use, and monitor these models thoughtfully, always staying aware of their strengths and limitations.
That's an excellent way to put it. Here's what we've learned today. LLMs are digital brains trained on oceans of data, powered by smart architectures like transformers, and constantly improving through innovation. They're revolutionizing everything from healthcare to hospitality, but they need to be carefully designed, monitored, and understood to realize their full benefits. Adam, thank you so much for breaking down this complex world for us today.
Thank you, Alex. It's been a pleasure, and I hope more people feel empowered to explore and question the AIs in their lives.
Absolutely. To our listeners, remember, as language models become more common, understanding their workings isn't just for techies, it's for everyone. Stay curious, keep learning, and join us next time on the Trending Tech Show as we unpack more of what shapes our digital world.